All right, here's this is going to be a class for Wednesday, the 19th of September for CET 120. And I'm just going to start out. We're going to open up our project seed file, our original drawing. Basically, we don't really need any dimensions on this particular exercise. We're just going to have our blank title sheet and our title block, and we're going to go back to our default model. And we're going to create a new model now. And I'm just going to copy the default. And we're going to call it Raster Design 1. There it is. We'll close this out. You'll notice down at the bottom we are actually working in Raster Design 1 model now. We're going to go to we'll create a level. Just right click, new. This one's going to be called Raster Design. Close that out, and we'll make Raster Design our active level that we're going to be drawing in. I'm going to draw in a color that's fairly bright so that you can see it better. We're not really paying much attention to our pen tables in this particular exercise. Now, what we're going to be doing, this is a raster exercise. A raster image is simply a series of dots. A photographic image, any kind of digital image, is going to have raster information in it. And the raster information we're going to be looking at is this particular sheet from a workbook. It's 4 exercises in bisecting an angle. So we're going to take a look at this and see if we can do all 4 of these exercises. The original intent for this workbook was to print these out or pull them out of a workbook and do them by hand with a compass and straight edge triangles to find bisectors of angles. And what I'm going to do is show you how to do this on the CAD program by bringing the raster image in as a background, and it's what we used to refer to as heads-up digitizing. It's more just raster vector drawing now, and we're going to be able to print this out. Actually, we'll actually put it on our title block in the end. If we look up here at the top, and I'll kind of zoom in on this area, the exercise is all about finding the bisector of two angles. So if we were to come out with any particular radius here, we could swing an arc from this point and then an arc from this point, the same intersection point on both legs of that angle, and find this center point and then draw a line through this intersection back to the vertex of the angle. So it's pretty easy. So what we're going to do now is go back to our Microstation, and we're going to reference in this raster file. Up here at the top we had our models tool, and then we've got our reference tools, and right next to that to the right we have Raster Manager. Just left click on that, and we're going to say File, Attach, Raster. We're going to go find that bisector, which is oh, there it is right there, Class 4 Monday. I'm not sure where it came from, but we'll use it. You'll all have a copy of this. I'll upload it to the first class so that you can download it from that site on Wednesday. I'll probably put it in there Monday, but this is the drawing. So just say open. We don't want to place it interactively. We're just going to place it because it was scanned at full scale. That's where we're going to place it on the drawing. So we'll just say open and attach. And we do a fit view now. There's our raster image in the background. So let's start with this first number 1. It says a pulley will be attached to a ceiling with forces applied to its cables in the direction shown. Where will the pulley support cable be attached to the ceiling to offset these forces without changing the pulley's position? So we've got a force pulling in this direction, which is also pulling in this direction. So if that's the case, this pulley is going to have a tendency to try to pull sideways. So we need to determine where along this ceiling line the anchor needs to be to keep the pulley in the right direction, which is a bisector of this angle. So to do that, we are going to trace, first of all, and you can't snap to a raster image, so you more or less just have to eyeball it. We're in our Smart Line tool. We don't have join elements. I'm just going to trace this along this line and let it pass right through. And then we're going to do the same thing to this line, just trace it. You're just left clicking and letting it trace and cover that black line as much as possible. So what we're doing is creating two vector lines that we can snap to then to find this angle that we're looking for. If I trim these off now to their intersection, this line to this line, using the 7-4 tool, and I think what we want to do is place these lines. I'm going to take this one, and if I hold down my control key, I can select a second, third, or fourth line, but I just want to select these two. And I'm going to use my 3-4 tool to move this roughly to the center of this hanger so that it replicates that angle. I think they may have intended it to be down here, but I think realistically we want the pull force to be off this point here. So now we need to find the bisector of this angle. What we can do is just swing an arc. We'll just take, this is the shorter leg, so I'm just going to take this point right here. I'm going to hit my tilde key, come back to this center point of the circle, and just swing this arc until it touches this line. Now, these computers are easier to deal with than running compasses and protractors, because we know that by default Microstation can find the endpoints and the midpoints, because this, if I hit spacebar K, you'll notice it's set to 2 snap divisors, so it'll find that midpoint not only on straight lines but on arcs. So if I find this point, bring it through the center point, it actually rotates my compass. You'll notice my AccuDraw compass is now rotated to that angle, and I can just left click, and that actually solves the issue right there. So I can unselect these, and there is my bisector angle. This would be the location that we would want to hook this to the ceiling so that when it pulls at this angle, the pulley would stay straight. Okay? Let's go to object 2. Again, we've got 2 angle walls. We've got a light symbol out here. So the first thing we want to do is kind of retrace that light symbol. We're going to take our E1 tool, place circle. Let's change our color just to be different here. Let's go to this dark green. And again, we just have to kind of, I'm just rolling my mouse ahead. We're going to kind of find this, roughly the center point of this circle. Bring it out to the edges. We'll draw a little line here. Remember, Microstation should index that size. So there's our light symbol. If I select this whole thing, here's a new simple keystroke command. It's a 2 keystroke. Hold down your control key and hit G. Control G groups this now into a single element so that we can move it around without selecting the whole thing. So that light symbol is actually one piece now. Okay, we'll do this one even a little simpler. Take your smart line. We're going to find this corner and just draw a line out. Let's go out a specific distance. We'll go out a distance of 3. It's actually 3 inches. And then we'll go up a distance of 3. So we know these are exactly the same length. Find this endpoint, hit our tilde key, come back to the center, swing the arc. So now we need to find the center point. Again, simply find the center point of the arc, bring it down to the vertex. And this should be, if we measure the angle, if we look down at our measuring tools, we can measure an angle under this D tool. Here's measure angle using yes. And down here at the bottom it tells us it's a 45-degree angle because this was a 90-degree corner. Roughly, it's a little scanned off, but it's close enough. So now we're going to take our move tool. We're going to move this right to the center, and it says under the directions, to provide a uniform lighting to two walls, overhead light fixtures are to be located at 4 feet on centers along the bisector of the angle formed by the two walls. Use the light symbol given to indicate placement. So if we start right here in the corner, I know I need to be out, and I'm just going to keep selecting until it selects my light back. There we go. Well, shoot. Sorry. There. There it is. So I need to move this line along here. If I hit my space bar, you see down at the bottom it says XY coordinates. I'm going to hit space bar so it goes to distance angle. And the first distance is 4. And tab. Actually, in this case it wouldn't be 4, it's going to be 1. Because this is a 1/4 inch equals a foot, and we brought it into full scale, so it's going to be 1, because there's 4 quarters to an inch, so this would be 4 feet. And then if I hit my N key, it's 1 and 45. Now I'm going to take my copy tool, find it again. Now I type in a distance of 1. Hit the tab key so it moves it over into the angle. Hit N. There's the second light. And then, I don't know how many lights they wanted here. We'll put one more. But what I want to do is extend this line out a little further. We'll go to our copy. 7, 3 is our extend line. And we're going to hit the tab key. We type in 1 again. Tab moves tabs between distance and angle down here. And hit N for nearest. There's the next one. I could actually, let's put one more on here. Just hit tab so it focuses over on the distance again. And tab 45. So there are 4 lights spaced 4 feet apart on a 1/4 inch equals a foot. Because we put this on here at 4 feet, we measured out from this point 1 inch, 2 inches, 3 inches, 4 inches. So each of these distances on a scale drawing would equal 4 feet, 4 quarters to an inch. Okay? Simple enough. Let's get down to this next exercise. And this is a theater. You can see that this is what they want to see on the theater. So first thing we'll do again, let's change our color again to be a little creative. Let's go to this, we'll use this blue color. And again, we'll just trace with our smart line this line. Now you notice my compass is rotated. If you hit the letter V, it rotates your compass back to so it's square. This isn't really square, but we'll get close to it here, just because the scan was a little off. So you can see this raster image. You see how those dots are on there? The difference between the two. So there's our 2 angles. Okay, so now let's just do another radius. This time I'm going to left and right mouse button like we did in the previous exercise. Left and right mouse button, hit O, and I'll just go up here, this far. Hit the tilde key, puts us into arc mode, and just swing an arc across here. Let's trim this 7.5 to this angle, so that separates our arc. And let's find the divisor right down the middle first. There's our center point. So there's this aisle right here. Now we need to find these two. We could break the line into 2 separate pieces, but let's do a spacebar K, and we'll change this to 4 segments. So now we can find this divisor and this divisor. So now we have our 4 sections. We want to take this one a little bit further. Let's do this. Take your, this is 3.9 is move parallel. We're going to say make copy. And I'm going to move this one, copy at 0.05. Oh, that's angle. I'm going to put it back in XY. Had to hit the space bar down here, sorry. 0.05. We'll move this one. 0.05. I'm going to do that to all. Parallel just moves it perpendicular. Okay. Now what we're going to do is take our parallel tool and let's just move this in 0.2. Yeah, that'll work. We won't do exactly the same number. We're just going to show you how this would. Whoops, jumped the gun. So let's leave it just like that for now. If we break element at each of these locations, pardon my silence while I'm breaking lines. Here we go. And then we'll just take our 7.5 tool, we'll trim this one. It makes a difference. You want to be on the end of the line that you want to trim too, so it doesn't make a backward circle on you. Sometimes, see if I can force it to do it. If I click back here and go here, see what it does? Control Z. I want to be on the end of the line that I want it to trim out. Sometimes it'll swing it backwards, so you got to make sure your cursor's in the right spot, or at least over the halfway mark. This is where if you've got the football game playing in the background like I do, you can kind of turn up the volume if you were. I don't want you to hear it in the background though. Patriots just lost to the Cardinals, so that's why I'm bumming in here in my den. This is mindless trim work, but when you get it done, it's kind of cool. They're just clicking, even though they look like they're touching, it's a good idea to trim them off anyway. So there we go. If I just take, this is a 5.1 as your change palette. If I want to just change the colors on these other ones, just so we can kind of see what's highlighted. And let's trim this bottom off here. So generally these look a little wider, but it's missing half of an aisle on this side. So this was 0.05 over to the side. So that is the exercise just in how to create that definition for dividing something, finding the bisector of angles. On the computer it's much easier. Our last exercise here is a end view of a swing set located. It says locate the position of the swing when it is at its resting point, which is straight down from the angle, and determine the angle of swing on each side of the center position that is possible without danger of overturning the set. And I'm not exactly sure what they mean by that, but let's take a shot at least drawing the lines in here. I'll go to this this brown color. And I'm just going to, we'll zoom in and trace a line along this. Oops. Control Z to get off the circuit there a little bit. And we can grab both of these. And I want to move it right up. 3-2 is move to the center of this circle. that was probably not such a good idea. So what I want to do actually is make a parallel copy because it won't change the angle. So if you move this out, you see how they're both selected? You do a parallel, it'll stay, actually expands it a little bit. So we'll kind of leave it there. See if this trims out pretty much to the center. Come down to the end of this line, hit our tilde key to go into the circular mode, swing it around. So there's our arc that allows us to find the center point of this. You can see it's a little crooked, but this is the bisector of this angle. So there's our angle. If we actually take our rotate tool now, 3-4, and we'll set it to 2 points, and we'll make copy. If I select this object, find this center point, then I can swing this angle up. Now I'm not sure where the point is where the swing set will overturn, but I can swing it in this direction this far, and then we can go back the other way however far you want, but we'll just do this one angle. So say if we get up this high, then the swing set may have a tendency to tip over, but I'm not into the physics enough. But we did find the bisector of the angle here pretty easily. I'm going to do a spacebar K, just make sure it's back into our 2 key point snap divisor. So we've actually finished this exercise from the workbook using it on the computer. As far as turning this in for our homework, let's go to our title block. There it is. We're going to rename. I know I screwed up the last time because I renamed the last one the wrong thing, but we'll just call this Project Raster. We'll leave it at A1. We'll change the date. Should be the 19th when we do this. All goes well. Now, what we're going to do is just like a regular drawing, we're going to reference that into this title block. So we're just going to say reference, attach, go find our, and make sure I get the right one. And I didn't change it from, probably should have changed that from Project C to something else. I'll have to clean that up later. Should have planned ahead. Alright, there's my raster design 1. Remember, if you go back all the way to the beginning, do a save as, so you don't have to clean this up. But if you go to class, you won't have to be reminded. Raster design 1. We're going to put it in as a top view. Hit OK, and just place it on the screen anywhere. So there's the drawing. You can see that it kind of goes outside the screen. If I double click, we need to make it a little bit smaller. Let's put it in at 1 to 2 would be half scale. And that's too small. So let's say 1 to 1.5. Not really a scale, but it works. It's actually a 2 to 3, so it'd be a 2/3 scale. It's actually not to scale would be what it should be. So there's our drawing. We've placed it in there. I'm going to say, let me just try that 1 to 1 scale again. I just want to try something. And it doesn't quite fit. So it's 2 to 3. No, not 2 to 1. We'll get into scales a little bit on it, but the 2 to 3 scale, the 2/3 scale should work. If we disconnect this, that disappears. So when we go to print this, now the one thing, our pen tables don't cover this, so it'll actually be a color drawing. We do a Control P. Resymbolization. We still want to attach our pen table. Because that makes our title block. And if I do a fit view here, there's our drawing, our workbook sheet in our title block. So everything looks kind of cool. Close this out. We're just going to say print. We're going to put this into our PDF directory. Right here. PDF. There was our project 2. We're going to call this one Project 3. That's what your folder will say in first class to turn it in. Hit save. It's done. Doesn't take you very long. We minimize Microstation now and do a file open. We'll open up Project 3, and there's our drawing file, and we'll dump this right into our folder. So 20 minutes on the computer. This was the fast Reader's Digest version. I think probably it'll take us a little bit longer in class to get this all explained, but this is the planned class for Wednesday, the 19th. Thank you.